Ever get that rush when a tough math problem just clicks, like boom, there's the answer? That aha moment is pure magic.
It is.
But can AI, actual artificial intelligence, experience that same spark of mathematical insight?
It's a fascinating question.
It really is. So today, we're diving deep into that very question with this paper, co-authored by Yoshua Bengio.
Oh, wow. Bengio, he's like a legend in deep learning.
Exactly. So if anyone can help us crack this, it's him.
For sure. So what's the angle they're taking with this?
They start by comparing how our brains work to how AI systems are operating right now. Like, think about those large language models, ChatGPT, all those.
Right, right. They're amazing at mimicking human language. It's kind of freaky how good they are.
Totally. They can write a crazy convincing email, even a poem, if you ask them nicely.
It's wild. And that's because they basically mastered what's called System 1 thinking. It's that fast, intuitive stuff, recognizing patterns.
Okay, so like more instinct than deep thought.
Exactly. But when it comes to math, it's not just about recognizing patterns. It's about that deliberate, step-by-step reasoning.
System 2 thinking, right?
You got it. And that's where AI still has a long way to go.
So it's like AI can write a perfect sentence, grammatically speaking, but ask it to understand the logic behind a mathematical proof.
Exactly. And that's a really insightful way to put it.
Well, I try. Take the Pythagorean theorem,
Classic.
right? It's not just some random formula. It's like a fundamental truth about triangles, right?
Absolutely. And proving it, that requires logic, deductions.
And that's where AI stumbles.
For now, at least, it's just not there yet.
Okay, so that makes sense. But here's where this paper gets really mind-blowing. They basically say that our brains, even with all their limitations, might actually be better equipped for math than, like, a supercomputer.
Now, that's a bold statement. I would have thought it was the opposite. More processing power, more math skills.
You'd think so, right? But they focus on this idea of working memory. We can only hold so much information in our heads at once.
Oh, right, the whole 7 plus or minus 2 thing.
Exactly. And they argue that this limitation, it forces our brains to get creative.
Creative? How so?
Because instead of remembering every single detail, our brains are constantly looking for shortcuts, for those core principles that unlock a ton of other information.
Huh. So it's like our brains are forced to find elegant solutions because they can't handle all the clutter.
Exactly. And that act of compressing information, of finding those elegant representations, that's super similar to what mathematicians do.
When they're coming up with theorems.
Exactly. Okay, I'm with you on this whole compression is key idea.
Yeah.
But how does that actually work with, like, real-deal mathematical theorems?
Well, get this. The authors of this paper, they suggest that you can actually judge a theorem by how much it compresses information.
Whoa, whoa, whoa. Too much, too fast. So you're saying a good theorem is like, what, a zip file for math or something?
Kind of. Imagine a library, right? But instead of books, it's got every single true mathematical statement ever.
My brain hurts just thinking about it.
Right. Total information overload. But now, imagine you've got this super powerful theorem. It's like a master key that unlocks a whole bunch of those statements all at once.
So you don't need to remember every single one separately.
Exactly. You can derive them all from that one elegant theorem. Bam! Mathematical compression in action.
Okay, that is a seriously cool way to think about it. So instead of just, like, being impressed by how hard a theorem is to prove, we should be looking at how much it unlocks.
You got it. How many other truths suddenly become obvious because of this one idea?
Right, right. It's like a domino effect of understanding.
Exactly. And here's the kicker. They actually suggest ways to train AI to spot these high-value theorems.
No way. So it's not just some, like, abstract idea.
Nope. They're talking about actual methods, algorithms. It's pretty wild.
Yeah, that's what I'm talking about. So is this AI sifting through existing theorems, or are we talking about something even crazier?
It's about trying to push AI to develop a sort of mathematical intuition, you know?
So we could look at a theorem and be like, ooh, this one's a keeper.
Exactly. They even talk about this AI called a G-flow net.
Oh, what now?
A G-flow net. It's designed to explore and come up with different solutions.
So hold on, you're saying we could have AI generating not just any old theorem, but ones that have a shot at actually being, like, useful to mathematicians.
It's still early days, but the potential is there.
Okay, let's say we've got AI picking out promising theorems like a champ. Can it actually prove them on its own? That feels like a whole other level.
You're hitting the nail on the head. That's the million-dollar question. The authors, they bring up reinforcement learning.
Isn't that where the AI learns by, like, trial and error?
Exactly. It tries stuff out, sees what works, gets better over time.
So it's like an AI wandering through a maze of math problems, bumping into walls until it stumbles on the solution. I can see how that might work for some problems, but I
Yeah.
mean, mathematicians don't just like randomly try stuff till they hit the jackpot, right?
Definitely not.
There's got to be some kind of intuition going on, some educated guesses.
Absolutely. They come up with conjectures, which are basically educated guesses about what might be true. And they often try to break a big problem down into smaller, bite-sized chunks. Lemmas, they call them.
Okay, lemmas, got it. But it's still, that's got to be so much more than just raw processing power, right?
Right, sure.
It's like strategy, knowing where to focus your energy.
Exactly. It's about being smart with your effort.
So how do we even begin to teach AI to do that? To be more, like, strategic and clever in how it tackles these problems?
Well, that's the million-dollar question. And the authors of this paper, they actually explore this idea of training AI to be more like that.
You're kidding. So, like, imagine an AI system that could not only pick out interesting theorems, but also make its own guesses about what might be true, test them out.
Exactly. And then break them down into smaller steps, search for proofs along the way.
Whoa. That would be like having an AI partner in crime for doing math.
Exactly. And think about it. What if the AI could see connections that we, even with our amazing human brains, just totally miss?
Right, like we're so used to thinking about things in a certain way.
Exactly. What if there are these hidden links between different areas of math that no one's ever noticed before?
And the AI could be like, hey, why don't you try looking at it this way?
Precisely. It could open up whole new avenues of research.
So it's less about AI replacing mathematicians and more like AI giving mathematicians superpowers.
Now you're getting it. That's exactly the point they're making.
This is blowing my mind.
It's not about replacing human ingenuity. It's about amplifying it. Like taking the best of what humans are good at, that intuition, that creativity, and combining it with the sheer power of AI.
To unlock a deeper level of mathematical understanding.
Exactly.
So big picture time. What's the ultimate goal here? We
Yeah.
can actually create an AI mathematician. What would that even mean?
You know, the authors bring up this really interesting idea. They say, if we can actually build machines that can think mathematically, like really truly think that way, it could tell us something really profound about intelligence itself.
Whoa. So not just artificial intelligence, you're talking about our own intelligence too.
Exactly.
Okay, so it's not just about advancing math. It's about using math to understand our place in the universe.
Right.
That is a seriously mind-blowing thought to end on. So, if a machine can help us make sense of math, could it also help us unlock secrets about consciousness, about creativity, about like the very fabric of reality? It really makes you wonder. Thank you so much for joining us for this incredible deep dive. Make sure you check out the show notes for links to the paper and all sorts of other cool stuff. We'll see you next time.